Chiral organic molecules are essential for modern medicine. Chemists today are constantly looking for more efficient and environmentally friendly ways of preparing them. Organocatalysis helps the chemist design a greener synthesis. Two leaders in the field of asymmetric organocatalysis, Benjamin List and Keiji Maruoka, have edited two Science of Synthesis volumes on the topic.
You've been working in the field of asymmetric organocatalysis for about 12 years now. How has this area developed and what is the current status of it?
Yeah, that's an interesting question. I mean, 12 years ago, the field of asymmetric organocatalysis as a field basically was inexistent. And this has so dramatically changed over the last decade or so. Now there are literally hundreds, if not thousands, of people working in this field. There's hardly any pharmaceutical company not using organocatalysis anymore, at least on one or the other level. And I would say this is almost a little revolution in asymmetric synthesis that is occurring right now.
Considering the progress that has been made in this field, you must have felt the time was right for a comprehensive overview of the subject, as provided by the Science of Synthesis volumes on asymmetric organocatalysis.
Yeah, exactly. There had been already books, there have been special editions, there had been teaching courses, all sorts of things are now going on. But we felt that a really comprehensive treatment by the very best people in the field describing their own field was missing. And I think that was the intention of getting into making this two-volume set.
Okay, and what would you say is the overall goal of these volumes?
So the field, as I said, was growing like exponentially, even explosively, people have said. But there is still, I guess, an element or a certain degree of not really understanding and appreciating the field fully. So people don't really know, for example, how to classify organocatalysis. There's all these different reactions, protein catalysis, Brunset acid catalysis. But how do we organize all this? How do we put this together? And this was, for me, the main driving force in making this, because Keiji Maruoka and I have come up with a way of organizing the field, based on a very simple definition. What is organocatalysis? Organocatalysis is the catalysis with small organic molecules, where a metal is not part of the active principles, and they function by either donating or removing electrons or protons. That's all there is. This is the whole field of organocatalysis, and this defines four distinct areas, namely Brunset acids and bases. These are the catalysts that donate or remove protons. And Lewis acids or Lewis bases. These are the catalysts that donate or remove electrons. And this defines the two volumes that we have. We have the Brunset volume and the Lewis volume. And this wonderfully is suitable for organizing this entire field and giving it a real structure. And I think that's a value for itself.
And what makes the Science of Synthesis volumes on asymmetric organocatalysis so valuable to the wider chemistry community?
So the way I came up with this, classification of organocatalysis was actually from teaching it. So I'm giving a course on organocatalysis at the University of Cologne since many years, since 10 years now. And when you go in front of the students, you have to have some kind of organization. And so I came up with this idea of doing it this way. And the one thing I immediately noticed, when classifying organocatalysis is you find all of a sudden areas where nobody's working on. For example, Lewis acid catalysis. There's very, very little asymmetric Lewis acid organocatalysis. And you can see this in the chapter in the corresponding. It's like the smallest we have in the two-volume set. And so we realized this, and that was for me an encouragement actually to start working in this area. So I think this really is inspiring, this organized structure of this book.
And how do these volumes differ from previous treatments of the field?
First of all, of course, it's comprehensive. So you can use this, for example, for teaching. But it also has what Science of Synthesis always comes with. It has experimental procedures. It has evaluated methodologies only, so you don't even have to go to the original literature to start your synthesis project. You can straight away take the book and start a synthetic reaction in the laboratory. I think these are the main characteristics. Plus, I forgot even, it's written by really the experts in their respective areas, all the leaders of the field. Macmillan has, for example, 2 chapters, one on ammonium ion catalysis, one on SOMO catalysis. Keiji Muraoka has written a chapter on phase transfer catalysis. So in Brenzett acid catalysis, both Terada and Akiyama have a chapter. It's really, really written by the leaders in their respective areas. This is also true for all the other chapters in this book series.
How do you think these volumes will help organic chemists address the challenges of the future?
That's a good question. I hope they will. As I said before, I mean, for me, this organized structure helps you really in identifying things that are missing. Right now, I think one of the hottest aspects of organocatalysis, even though it doesn't sound so hot, is substrate scope. And to me, this is really key in establishing new methodology in organic synthesis. And from the organized way we have assembled this book, you can immediately identify, what kind of substrates do not work with each other. And that, I think, helps scientists in identifying great research topics.
To find out more about the Science of Synthesis 2-volume set on asymmetric organocatalysis, please visit thieme-chemistry.com.